So yes, I'm a director of Sun Earth System Sciences. That doesn't just mean all the sciences between the sun and the earth, which is kind of a joke I like to throw out there, although it is a lot of science. Anything that the satellites can see looking down or looking around, that's the science that my team is working on. We're about 40 engineers and scientists here at the Canadian Space Agency. But most of you would sort of think about it as science missions, and I'll get to talk all about them today. So thanks for tuning in, and let's hit the road because I'll talk for about 25 minutes and I want to leave time for questions. So the Canadian population is scattered across 100 million square kilometers. This is a phenomenal image that was taken by the RADARSAT Constellation mission. It's a 3D image of Canada, coast to coast to coast. We have the largest coastline on the planet. So we have so many challenges, and satellites are there really to help us in such a great way to address a lot of those challenges, our dynamic environment, the vastly changing climate and the landscape and the coastlines. It's really impossible to do this all from the ground. So this spurred Canada to rapidly adopt the use of satellites back in the 1960s and 70s. We started with synthetic aperture radar. We became masters of the trade, and we boast some pretty incredible satellites today that I will bring to your awareness. Earth observations, and I know you've had a series of great speakers today, and you've probably learned a whole lot, so I'm just going to repeat it in one sentence. It is defined as the gathering of data about the Earth's physical, chemical, biological systems using satellites. Every single day, Canadian and international satellites are meeting the needs of multiple users in Canada and around the globe. Let's take a look here at the Sustainable Development Goals. Let's get comfortable with them for a minute. Take a moment to absorb all 17 and consider what you might already know about them and what you might already know about countries taking action on all these, because they were put out in 2015 with a 15-year agenda, and many countries of the world have adopted this major effort to face, to challenge, to tackle all 17 and to monitor and sustain them. I also want you to take a moment to consider if you had to propose to take action on any of these areas and monitor progress. What would come to mind about how you would do that? Today, I intend to build your appreciation of how our satellites, both the Canadian and world satellites, are delivering on critical data and services to meet these goals. So just simply putting that into words and showing you, our satellite technologies are playing an important role. And EO data is essential to meeting these science-based decisions. And I have a Canadian slant on this. I'm telling you this from the Canadian standpoint, but I challenge all of you to ask your decision makers in your countries how you're meeting these goals, and if you're using satellite data to do that. Let's take a moment. I'm going to play a video. It's 1 minute long, and it just sort of lets you absorb this Canadian landscape that I'm in, and how we're using our satellites to address challenges. And Nicholas, you're welcome to interrupt if you can't hear the sound, but I think it should go all right here. So 1 minute of taking a journey across Canada. It didn't work. Sorry, let me try this again.
Yes, we can hear loud and clear.
All right, we just revealed a new logo today. So a shout out to anybody who's seen our new logo that is just hitting the press today. No more blue meatball. We actually have a really cool 3-star and a Canadian maple leaf system that you can go check out online. So we've talked about what we do and why we do it. Who's doing this? It's the satellites. And this is one of my favorite slides. And I could talk about it for hours because I appreciate every single one of these satellites, but I can't take all that time. So I'm going to spend 1 minute telling you that these satellites are mighty tools. They're really powerful, and they're up in the sky sending data down to us to tackle our problems. The Canadian satellites are mostly along the bottom. The RADARSAT constellation mission that I talked about earlier, 3-dimensional data. I will say, every one of these satellites has like a superpower. You could ask a satellite developer, what's the sensor package and the instrument that's on board that makes it so powerful? You should always ask that question to a satellite builder. We would tell you along the bottom, these Canadian SAR, synthetic aperture radar, it's incredible technology. It can give you very high resolution movement of coastlines, of bridges, of roads. It also has, the coherence so that it knows when there's shifts, right down to very, very small angles and measurements. So we have been very good at synthetic aperture radar since the 90s, all the way out to recently in 2019. Our most recent triplets were sent up into space. Over on the right, SciSat. It is a aerosol satellite that was sent up in 2003 to monitor aerosols and aerosol depleting substances, of which there's a very, very long list. It has an incredibly long data set. It's turning 20 this year. We expected it to last for 2 years. And this is a story you'll often hear from satellite builders. They're really going strong and long. We're going to celebrate 20 years this year. And you might think it gets older and it gets less relevant, and it's the opposite. Those data sets that go back out through so much time are there to tell us about the changing. It's a witness to the changes in the atmosphere. So SciSat, a really exciting satellite. The ones across the top are Canadian contributions to international satellites. And I could talk about them all, but I'm going to pinpoint one of them, SWOT. I have a whole slide on SWOT near the end of my presentation. Surface, water, ocean topography. That Canadian landscape, 20% of the Earth's fresh water is in Canada. So mapping all the surface water, the fresh water, the oceans, we've never done it before as a human species. We've never mapped all of it. And we don't even know if Canada has 1 million or 2 million lakes. We're going to find out soon. Everyone's guessing. So that satellite is going to go get an inventory like we've never had before, but it's also going to get altimeter data. So it's superpower, it's altimeter. It's able to tell you river discharges, coastal currents. These satellites have incredible information, and it takes more minds like yours to get out there and make discoveries with the data sets. Let me just do a little animation so that you can appreciate what each one of them really specializes in. And again, your takeaway from this slide is every single one of these satellites has a specialty, it has a superpower. Ask more questions from people who work on satellites. They will proudly tell you what the satellites do. Every country put strategies forward, and Canada's space strategy came forward a year ago. It was announced by Minister Champagne in support with other ministers in the government. And I'm quickly going to tell you that as you hear me talk, I hope you'll hear, and it will resonate, that I will be focusing on some of these key aspects of our strategy. There's an economic aspect to ensuring that our data is open. We have an open data policy, really following the leads of so many other space agencies, that it allows us to maximize the use of this data. We have environmental reasons in our strategy to pursue our work in space, and that is to harness EO data for climate change, to strengthen delivery of critical services. You're going to hear me say a number of times today, critical services, new apps, things like this that impact people's lives. That's our environmental axis of our strategy. And finally, on the social side, inspiring skills, capacity development, get those new minds into our realm. And that is why I take time to speak like I do today, is we need help. We need support in this space industry to bring minds together, because we are not going to do this alone. We don't do this alone as a country. We don't do this alone as individuals and in industry. And I'm sure you've been hearing that as a resounding thematic from many speakers today. I'm going to launch now into 5 examples of how we're meeting those sustainable development goals. And you can point out the goal, you'll see the goals kind of along the bottom, but I think it's really important that you know the satellites are really delivering on all the goals in many, many ways. And I will have fun telling you about 5 in particular, either services to Canadians, applications that we're developing, or other ways that we're pushing data products in EO that are really affecting people's lives. So I'll start by talking about weather, climate action, clean water. So first question to you, did you know that the Government of Canada alone receives millions of observational data points every day from satellites that are orbiting the Earth? And they're passed through complex computers doing numerical models, and they provide daily weather information. But beyond that, very importantly, those forecasting models are helping with public safety in a number of ways, as well as for aviation hazards. You can think of low clouds, thunderstorms, hurricanes, evolution of dust plumes. More than 90% of the data that goes into weather models come from space. I don't know if you realize that. It makes satellites critical to delivering accurate and timely weather information. Water quality. The image in the background, I want you to take a look at it. We call this satellite art. If you Google it, you'll see all these gorgeous images come up, and you can use them on backgrounds and you can post them in your office, but they tell stories. And I'm going to tell a story about this one. This image is Lake Winnipeg. It's the world's 12th largest lake. The image is from 2017, 10-meter resolution data using Sentinel-2. The green areas are algal blooms. Not a good thing for our lakes. The dark areas are relatively clean water. And the bright water is areas that are really reflective by the suspended sediments that are near the surface. But the Government of Canada has really needed to launch a service in order to track these algal blooms. And we call that the EO Lake Watch. We deliver satellite-derived products so that we can monitor our lakes and also understand the causes of these algal blooms. One incredibly important service to Canadians. The next example is about using EO data to increasingly support assessment and monitoring of geohazards, such as landslides and pipeline corridors, earthquakes, volcanoes. A concrete example is wildfires. That's the background picture. They threaten the safety and well-being of all the humans in their path. And they have a substantial financial toll. An example was the Fort McMurray fires in Canada just a few years back. We believe the financial toll was near 9 billion Canadian dollars. With proper intelligence and using views from space, we will be able to better pinpoint which fires and areas are the most intense, which is sort of depicted by these red lines. We need first responders and the boots on the ground to tackle really the most intense fires, the ones closest to communities, the ones propagating fastest. We need to use the very limited resources that we have for firefighting to tackle the ones that are the most dangerous, the highest threat. I'm going to refer to a satellite called WildfireSat at the end of my presentation, because since this slide was made about a year ago, we've had the announcement here in Canada that we will have the first dedicated satellite system to fighting wildfires. Currently, we use data from all sorts of different satellites, but we really need to know the data at a certain time of day. We need to tune that satellite system for the wildfire challenge. And I'll speak to that satellite system at the end of the presentation. Floods are a threat to us all worldwide. Satellites are helping behind the scenes. They're playing a critical role. And We also coordinate emergency response internationally. And this is through a activity called the International Charter of Space and Major Disasters. Hopefully you've heard of it, but the idea is that all participating countries, 17, I believe, to be factual, point their satellites to where there is a emergency, wherever the area of concern is, and promptly share that satellite data so to assist for people and infrastructure and reduce damages. Third example, here's how it feels in Canada right now, a little bit in the winter season. Satellites can be used to monitor air pollution. SciSat, I showed you earlier, is monitoring aerosols. Exposure to polluted air can lead, we've got Healthy Canadians up, right? We're good. Exposure to polluted air can lead to a number of adverse health effects. If you've heard of it, there's daily values that are put into the Air Quality Health Index, the AQHI, a very important index and a great service to people worldwide. According to the World Health Organization, 75% of emerging infectious diseases are of animal origin. Of particular concern in Canada is the distribution of the vectors of vector-borne disease, vectors on ticks and mosquitoes. So carrying those diseases such as Lyme disease and the West Nile virus into new habitats. And this is particularly problematic in Canada, as many of those habitats were more south of our border and are emerging northward. So I'll give you an idea of how our EO satellite data is helping to solve that problem. We use our data for early signal of the risk of infectious diseases. So when we combine the EO data with socioeconomic information, we can come up with vulnerability maps. And this is what you're looking at. As you see that vulnerability, the red hot issue areas sort of working their way and evolving rapidly over time. This was seen in southern Quebec. This is about where I'm located, where you see on the map. And it could tell us where we're at risk now, and it could tell us where we're going to be at risk in the future. And it's a fundamental starting point for public health risk management. I'll just last mention is throughout the global COVID pandemic, these maps were used to understand the potential for the spread of COVID-19, showing how EO has been valuable and successful in interventions for public health crises. Fourth example is with agriculture, sustainable agriculture and food security. You know, we have, satellites have an important impact on all the food we eat, and it is also helping with resilience to climate change. Imagine you're a farmer or an agronomist or a researcher, and you have an extensive field to monitor, and it's almost impossible for you to be able to see, because of the extent of that field, all the different areas and the moisture of the soil. By using apps that analyze data from space, you can monitor that soil moisture from one corner very differently from another, and you can make better decisions about the amount of water, fertilizer, and very importantly, pesticides that you should be using. It helps you in your operations, and at the same time, it helps the environment. In the graphic that's shown here, I'm going to click on it, animation. We're showing you that anyone can access these maps and data. It will tell you the level of moisture in the top 5 centimeters of the soil. And this is available across Canada on a weekly basis. We also produce the annual crop inventory service on a yearly basis, and it has tremendous impact on our agronomists in Canada. These maps are really courtesy of the SMOS satellite and SMAP satellites. And just a fun fact, the entire community is downstairs here at the CSA right now, gathered. There's people from Toulouse all the way out to British Columbia, Canada, talking about the great successes that they've had for one satellite launch in 2009, another in 2015, and they've been making all sorts of fantastic discoveries. My last example will be with our ecosystem protection and Arctic stewardship. Approximately 40% of Canada's territory is in the Arctic. And this is a region that is warming at twice the rate as the rest of the planet. Think about that, twice the rate. Canada has a strong interest and responsibility to monitor the environment for the health and safety of our nation and our global Arctic community. This environment remains difficult to monitor, and we really need this EO data that helps us look after environment in Canada, and it helps our northern communities, and it helps us make good decisions. The image in the background, it was taken in 2020 with a European satellite. It covers part of the Mackenzie River Delta, where the brown sediment-rich waters, the east arm, they meet the still ice-covered Arctic Ocean. This area is part of the Inuvialuit settlement region. A quick story that I'd like to tell is with respect to the North Atlantic right whale. We had Department of Fisheries and Oceans approach us a few years ago and ask us, could we track the whales from space? And the jury was out on that. Researchers were having a lot of challenges differentiating between a wave and a whale, for example. So what we did is a practice that's known quite well internationally now, is to do a prize challenge. Throw that question out to all of Canada and put in incentives that say, come up with an initial concept. We'll fund up to 5. We got 25 consortiums, not just individuals responding, consortiums of institutes with universities, with companies who pulled together and came up with solutions. We funded 5 out of the 20 some odd applications that came in. And I'm happy to say that they're about 2 years into their development. It'll be a gated process. So the best ideas will go forward in time. So a very exciting approach, I should say, to a very difficult question. Can you track the whales? Stay tuned for what will happen with that over time, because this is a very high impact application of EO data that could do a lot for our wildlife. And just to sum up my presentation, 23 for 2 minutes, I'm going to give myself 2 minutes to talk about the new missions that are coming down the pipe for my team, for Canada, for the Canadian scientists, universities, industry. First one, SWOT, was a partnership between NASA, CNES, CSA, UKSA. I got to go to the launch, a SpaceX launch in Vandenberg in California in December. That satellite is now up in orbit and in commissioning. The data, which I consider a stream of gold, will soon be available. And we have researchers all across Canada, excuse me, who are very, very excited to do discovery science based on this data. As I mentioned, we are mapping all this fresh water in Canada, fresh water across the entire planet. It is our responsibility. If we have 20% of the world's fresh water, I think it's absolutely our responsibility to take care of it. Only 10% of it is renewable. We need to be responsible. That's SWOT, surface water, ocean topography. The second one is WildfireSat, a truly, truly Canadian satellite system tuned for Canadian wildfires. We will share this data, of course, but the tuning of this is to fly over Canada at the 4 to 6 p.m. Time of day, which is the hottest, most intense period for wildfires. And that data will go straight into the hands of the planners. Overnight by 6 in the morning, they are deploying their resources, their drones, their aircraft, their boots on the ground, and they are tackling the fires that pose the greatest risk. It's an absolutely brilliant satellite system. We are working internationally through CEOS and other forums to work together to share that data and to really benefit worldwide, because wildfires are not just a Canadian problem. And finally, also announced last year, Canada will be part of NASA's truly incredible atmospheric observing system. We will contribute 1 satellite and 3 instruments, 2 on one of the satellites, 1 on a NASA satellite. Altogether, it's going to look like something like you see on the right. Japan, CNES, the French, the US and Canada working together. I put some details in there about what our superpower satellites are going to do. But in general, it's really to monitor and understand the changing climate. So with that, I'm going to bring it to a close just on time, 3:25. I'd love to hear any questions from the audience. Thank you so much for listening. And Here we go, Nicholas. Open the mic.
Perfect. So thank you for this insightful presentation, Taryn, first of all. And while the audience are casting their questions there, I'll ask you a few questions from myself. So obviously you shared very much in detail what a game changer the Earth observation and the satellites are for, let's say, not only the environmental, but also the industrial applications, right? So, and this was a great example also regarding the collaborative effort with the whale story that you gave. So my question to you will be, Taryn, so how do we make it so that the governments and the private companies work together to ensure the accessibility of the Earth observation data to the developing countries and all the stakeholders out there? So how do we make this happen? That's my question.
Yeah, that's a great question. I hear it raised quite often lately because the governments, we've all signed up for that policy, the open data policy, and allowing for accessibility and making major efforts. And we've made investments on that front to that effect. The industry, their response is somewhat different, which is we would love to have it to the benefit of all people for the common good. They use goodwill. They say we would love to be able to do that, but the bottom line is we need incentive to do that. So my suggestion is it's on a case by case. Every single one of these satellites have a very, very different target audience and commercializable capability. On a case by case basis, each of them has to be looked at for the ability to ensure that that data is accessible. And there's a lot of complexity to this because there's various levels of data, raw data versus processed data versus data that has analysis ready or value added already onto it. We are tightly coupled with industry on these discussions, and it is on the government to produce those incentives to help make sure that those are accessible to science. I do see that as our responsibility, Nicholas.
Absolutely agree with you, and that's a fair point. Absolutely. So we still got a couple minutes, so I'll ask you another question, Taryn. The question is with the Earth observation and its importance, obviously, and the private companies being involved with that. So how do they make sure that their Earth observation campaigns are carried out in an ethical way without violating the security and privacy boundaries, basically? So how do they make sure that?
Yeah, again, I think this comes back to us setting the tone in the government. We need to put the right policies in place. We need to be having the right conversations, and we need to be ready to invest in that whatever that responsibility is, we need to be able to invest in it. For example, WildFireSat, we started talking about 5 years ago, and we put money aside right up front that we would have environmentally sound disposal of that satellite at its end of life. We needed to think about that from the beginning. We didn't wait until we put out an RFP until we asked the question to industry, what do you propose? We actually imposed, but we funded this notion that it has to be responsibly disposed of at its end of life. And I know you just had a debris discussion, and it is on us. We take responsibility for that. There's also UNUSA and UNCOPUS, this peaceful uses of space. We all have to be on top of those incentives that drive responsible behavior. And it needs to be bounded by good judgment, good decision making, and ensuring that those decisions, those policies are adopted and adhered to.
Perfect. All right. So thank you, Taryn, so much for the questions, for the presentation. And while this unfortunately brings us to the end of the time slot, right, for the speaking, we would be very happy to see you, Taryn, again next year, and maybe even sooner than that, obviously. Once again, thanks for that. For the audience, if you'd like to cooperate with the Canadian Space Agency or with Taryn individually, right? So there is a link in the chat that you can use to schedule a private meeting with her, to reach out to her, request a meeting. So please make sure to do that. So